Okay, on the final then. First section is a limit problem. X is approaching something. You're going to end up with an indeterminate form, a 0 over 0 indeterminate form. Now, what does that mean? There are several ways to end up with a 0 over 0 indeterminate form. One way is to have a problem like this. That will give you a 0 over 0 indeterminate form. Because when x is approaching 3, the numerator is going to go to 0, and the denominator will go to 0 as well. To solve this, to actually do the limit, what do? You factor it, and you cancel common factors. Okay, that's simple enough. But what else can you possibly get? You could get a problem like this. This gives you a 0 over 0 indeterminate form, because as x goes to 0, this goes to 1/2 minus 1/2, that's 0, and that's going to 0. You have a 0 over 0 indeterminate form. What do you do in this problem? You multiply what?
The reciprocal?
Yeah, you could do a reciprocal kind of thing, but the bottom line is to multiply numerator and denominator by the LCD or LCM of these denominators. 2 times x plus 2, numerator and denominator. What you want to do is eliminate this complex fraction. That's what it is, a complex fraction. Okay? And what happens is the x plus 2's will cancel. You get a, here, I'll show you. X plus 2's cancel, you get a 2. The 2's cancel, you get x plus 2. The denominator is 2x, x plus 2. What you're doing is simplifying the complex fraction. Now, when you drop the grouping symbols, what happens? The 2's will cancel. You get the opposite of x.
How can you just cancel the 2's?
Drop the grouping symbols. You get 2 minus x minus 2. Okay? And now what happens? The x's cancel. Now, as x goes to 0, what happens? You end up with negative 1/2, and that's the answer. So, what 2?
In front of the X at the bottom.
That 2 right here in front of the x is still there, and you get a 4. Good call, you guys. Out of the way. It's negative 1/4 is the answer. Good call. What else? Go ahead.
Just to review, like when finding limits, you simplify the equation and then you just plug in the whatever number the limit is.
Yeah, because in the process of simplifying, whether by factoring or eliminating the complex fraction, what will happen is you'll eliminate the common factors that are causing it to be a 0 over 0 indeterminate form. But there's one other one. Let me just do this, Damon. You get this one as well. This is another 0 over 0 indeterminate form. We proved this with the squeeze theorem. What do you have to do in this one to get rid of that 0 over 0 indeterminate form? Yes, you want to get this to agree with that. You want to multiply by 5 and by 5 so that these two agree, and that limit's equal to 1. So the answer is 5. But look at your test on these limits, okay? Because these are the kinds of things in that test. So look at the test to make sure you understand. All right?
Is there going to be a couple?
1. Oh, no, a couple. There are a couple.
2?
There are 2 of those.
2 sine things?
No, 2 limits.
One of them's going to be a second, right?
Probably.
Probably.
Well,
You don't know, but
Yes.
How much do you want to know?
Yeah, I know. But there's another limit question that is separate from these, and that is the definition of the derivative. That is here.
That's a good boring.
Oh,
And
it's something minus, right? It's the one with the minus.
It's
yeah, so the
Minus.
minus, it's only minus.
it's the one with the minus, yes. Yes.
Because there's gonna be one with a positive, so.
Yes. So, yes,
What is it? Is it f of x plus h?
it's the limit. Did I use, delta x goes to 0. F of x plus delta x
Minus F.
minus f of x.
Oh, I use h's.
Or, yeah, you could use h's too.
Forget it.
All right, that's the first section, limits. All right, is everybody okay with that?
Can we, but the best way to study this is to redo all four.
Yes, yes.
Okay.
Okay, wait a minute, I gotta make sure Jeff and Gessner are okay. I don't want you guys to miss anything. Jeff, I don't want you to miss this. No, that's all right. I just don't want you to miss any of this. Okay. That's the first section. Then, the next section, 4 through 8, is find the derivative. Well, as you can imagine, there are derivative questions here. And again, the thing to do is look at test on derivatives, test 3. Yeah, product rule, quotient rule could be here. Quotient rule,
All of the rules, probably.
any one of them could be here.
At the end of the U
I have
form.
a question. Could you tell us if it's going to be an inverse one? You can. Like
Oh,
the
right,
derivative
yeah,
of the
inverse.
inverse?
No inverse?
No.
Inverse?
Really?
Well, I mean, arctangent or arcsine one?
Can you?
Yeah, you can have one of those. I'm saying,
That's what you said.
no, you said an inverse one. That's one they had in the homework. They gave you a function. They said, find the derivative of the inverse at a particular point. I won't give you any of
So
those.
there is.
But you should know, I'm going to list them. I'm going to list all the things you should know. Okay, you ready? Product rule, quotient rule. You should know implicit differentiation. Okay. You should know logarithmic differentiation. You may have one of these, and the thing to do is look at your test on the derivatives. If you can do the test, you can do every one of these on the final. Okay. Now, those are techniques. You should also know forms. You should know u to the n form. You should know e to the u form. You should know natural log u form. You should know sine u, cosine u, tangent u. I don't think I'd give you a secant. No, I wouldn't give you a secant, but you should know a secant u.
Was it on there?
No.
I don't even see it.
Well, you should know it. Secant u. You should know inverse sine u, inverse tangent u. That's arcsine or arctangent. I'm going to say inverse secant u, but the chance of me giving you that is practically 0.
Wait,
But inverse sine, inverse tangent, you should know.
sine was 1 over square root
Yep.
of 1 plus or minus?
Minus.
Minus u squared, right?
Yes, it is, du dx. And the tangent,
I forgot that one.
what's the derivative inverse tangent or arctangent?
I don't know. Is
Is
it 1 over, is
1
it,
over x squared minus 1.
no, is it, it's
Close.
still 1
Plus 1,
over,
plus 1.
Yes, plus 1. It's 1 over 1 plus u squared du dx. That's the derivative inverse tangent u. What's that?
So even if it's just like, if you gave us a number.
All right, let's do it. Let's do it.
Then you-
Let's do y equals inverse tangent of 2x. This is the kind of thing I would give you. Find the derivative. The derivative is 1 over 1 plus u squared times the derivative of 2x, which is 2. And if you look at your test, you probably have that very problem on the test. You know, I think it is.
Yeah.
So that's the typical kind of thing I would give you. Okay?
now, the secant is without the square root, right?
It is a square root.
Oh, it is a square root?
I'm not going to give it to you, but the inverse secant form of u, the derivative is 1 over the absolute value of u, square root of u squared minus 1 du dx. That's the inverse secant.
Wow.
I'm not going to give you that. It's one you probably should know, but I wouldn't give it to you. I would definitely give you either arcsine or arctangent, though. But I would not give you one of those on WebAssign where they give you a function and they ask for the derivative of the inverse function at a given point. I wouldn't give you that.
How about cosecant?
No, I wouldn't give you cosecant or
It's just a
cotangent.
negative sign.
Yeah, and cosine, yeah, it's just a negative. I wouldn't give you those. Okay, so you got those. I would ask you in this section, actually this is number 9, I would ask for find the slope of a tangent line, just so you know.
Isn't that just doing dy?
That's
And that's just finding the derivative at a point. That's it. It's really a derivative problem, but I just want you to be aware that I may give it to you in that form.
So it's
Oh,
just
so you
dy
just
dx
find the-
and then a certain
Yes,
point.
yeah.
Okay, and you just plug it in. Okay.
Yep. Okay, everybody ready on that?
No, hold on.
This is gonna be online though.
Yeah, still. Yeah, you're good.
Okay. Reading through there. You can read through there,
I
huh?
could, but
Wow, all right.
if you just, swipe it over,
Yeah.
I'll slow it down for
Yeah.
everyone.
All right, you ready? Okay, next section is given some function.
What do you think I said so close?
What about 11 and 10?
It's a mystery.
10 is in that slope of the, there's 9. 10 is it's another derivative. It's a derivative. It's a derivative one. 10 is a derivative.
So it's 9 and 10 is.
Yeah, 9 and 10 are
You might
derivatives.
as well just show us the exam.
Jesus, I know it. Holy mackerel. It's a derivative one.
Nobody wants to show us the test.
It's a derivative. What?
Give
Yeah.
it a 10-second lead.
Just put it on the thing, don't worry.
All right, 11 through 12 is given some function. Okay. Like the test you just had. I'm going to give you, a rational expression, and I'm going to ask about rising, falling, vertical asymptotes, find asymptotes. I'm not even going to ask you rising and falling. Find asymptotes. That's a rational expression,
Oh, okay. It's a group.
okay? Just find the asymptotes. That means a vertical and horizontal. Okay. But then I'm going to give you another one where I'm going to be giving you a cubic polynomial. And I'm going to ask for rising, falling, the thing we just did.
That's what we did, right?
Yeah.
Rising.
I'm not going to ask all of these, but I'll ask for some of
It's
them.
out of 25 though, right?
Yeah, there's 25 questions in
Okay,
all.
okay.
Then, next part. Actually, that is 3 questions. That's 13 through 15. Okay? And then 16 through 17. This is a max-min problem.
Next one, okay, that confused me.
Okay, that's a max-min problem. We had 2 max-min problems on your test. You're going to have 1 max-min problem, so it'll be similar to one of those.
Wait, on our
Okay.
last test? That's
Yes. Similar to one of those 2 that you had on this test, okay?
It'd probably be like 2-part.
1 max-min problem on your final, similar to one of the 2 that you had on your test, just not.
Okay.
Okay.
Sounds good.
How come it's 16 through 17? Wouldn't there be 2?
Yeah, there's 2 questions on that one problem, okay?
Which one do you think it might be?
Question.
18 and 19 are another derivative. What the heck I throw this? I have another derivative. All right, I have another derivative. This is a little bit more complicated than the easy derivatives from the first section. This would be like sine cubed of 2x or something like that. a little bit more complicated
Where
question.
You would move it to,
What's the derivative of this?
move the 3 to the front, right?
3 to the front, the 3 becomes 2.
2.
Okay, times, and now you gotta take the derivative of sine 2x, which is
Oh, cool.
cosine 2x times the derivative of 2x, which is 2. That would be the derivative.
Wait, I'm a little confused about it.
Okay.
So you moved it up from, the first derivative you took was the 3 that you moved up front. Then you took the u form of that, right?
U is sine 2x, so I took the derivative.
Which
Wait, hold on. First of all, this is a u to the n form,
Yes.
okay? Where u is sine 2x and the n is the 3. So the derivative is the 3, the u, sine 2x, squared now, because you have to reduce this by 1.
Yes.
Now you got to take the derivative of the sine 2x,
And be
And the-
cosine 2.
and that's cosine 2x.
Would that be the u form already?
Yes, it's another u form where u is sine 2x. No, I'm sorry. Jeez, I'm screwing that up on you. Okay, I'm going to start all over again. This is a u to the n form where u is sine 2x.
Yes.
The derivative is n u n minus 1 du dx. The derivative of sine 2x. Now, what's the derivative of sine 2x? That's a sine u form. The derivative of sine u is cosine u du dx. Now u is 2x.
Okay, is that so?
And the
so
derivative
you just
is
hit-
2.
You just keep moving over that.
Yeah,
u.
yeah,
Okay,
exactly.
That's what I was asking.
Danny?
Why don't you have a square with a cosine? You wouldn't have squared up there?
There's no squared here because you're taking the derivative of sine 2x.
The u form.
That is your u. You have to take its derivative, and the derivative of sine 2x is cosine 2x.
Ignore the cubed?
The cubed is taken care of when I did the u to the n part of it.
It's like taking the first derivative and taking its u form. You know how we move it over, put it in brackets, maybe that.
Yeah, yeah. Yeah, well, you know, this is, okay, that's a good suggestion. This is what you have. Okay? This is your u to begin with.
Yes.
The derivative is 3u to the n minus 1 times the derivative of this thing. What is the
That's the u,
derivative of that
that's the u.
thing? And now you got another sine u form. Another form, and it's sine u. The derivative of sine u is cosine u du dx. Now the u is 2x.
Do you get it?
Yes.
Okay.
You put the parentheses and something.
Oh, that was a good suggestion. All right, that's 18 and 19. Oh, 20 through 22 is one of those position ones, a related rate with position. Oh, man. 20 through 22, this is one of these position ones. This is giving you the position of a particle at any time t.
I like these ones. Oh, except I messed them up. Thanks.
I'm going to ask for position at a given time, at some time t. I'm going to ask for average velocity over an interval of time. And again, you should check your test because I'm sure I gave you one of these on the test.
Yes, you did.
Over some interval of time, usually starting, well, it doesn't have to be 0, but
If
some
we get the
interval of
first
time.
one wrong, can we get more credit on the second?
Yeah, I'll give you some. And then instantaneous velocity,
Which is the derivative?
yes, at t equals some time, t equals c, say. That's the easiest one of all. You just take its derivative and plug in the t value, okay?
The position one was that one right up there.
Yeah, position, you just plug in the t in this original.
Yes.
The average velocity, you should know. What's the average velocity? It's your position at t plus delta t minus the original position over delta t.
The derivative.
No, it's not the derivative yet. The average velocity is the difference in position, give you a distance over the change in time. That's your average velocity over an interval of time. The instantaneous velocity is the derivative. Let me give you an example. Let's do it. Let's suppose I give you this. You're on top of a 200-foot cliff, okay? And you you throw a rock up in the air at 40 feet per second, okay? This will give you the position of that rock at any given time t. Let's say you want to find the position of this rock at t equals 2. So S of 2 seconds. What's the position at 2 seconds? Okay. It's equal to 216 feet. In other words, it goes up, starts coming down, and it's still above your head. It's 16 feet above where it started. Let's find the average velocity from 0 to 2.
So it'd be 216 feet.
Yes, what you got to do is find the position at 2 minus the position at 0 over 2 minus 0. So it's going to be 216 minus your position at 0, which is 200. That's where it started, over the 2 seconds. 16 over 2. That's 8 feet per second. That's the average velocity over that interval of time. Your instantaneous velocity at 2 seconds is the derivative at 2. Well, the derivative is negative 32t plus 40, and we're going to let t equal 2. So it's going to be negative 64 plus 40, a negative 16 feet per second. It's heading downward, in other words. Okay, so it is coming downward. It's still above your head, but it is heading downward, okay, at 16 feet per second. That's the instantaneous velocity, okay? That's the kind of thing you're going to see.
And I'm guessing the last one's the square going outwards, right, or triangle?
Oh, yeah, you're right. A related rate, that's the last one. Very nice. Okay, everybody else set?
The last three.
Last three, 23 through 25, related rate
That's where we have to find the derivative and place it in.
with respect to time,
It's always respect to time though.
always.
Can you do an example?
Sure.
One of those?
Wait, what did you say this one is?
This one is a related rate problem. I gave you two kinds of related rate problems. It's going to be one of those two. The two problems that I gave you are a Pythagorean theorem problem, where we had trains leaving a station, or the other kind of related rate is a square or circle that's expanding, or a cylinder. I don't think I gave you a cylinder. I gave you a cone one, a balloon one. Those are possible. Those are all possible. You're going to have one of those couple. Which ones do you want me to do?
Could you possibly write down remind us the formulas for the cone, for the...
Cone, if you do get a cone one, the volume, 1/3 pi r squared h. If you have a sphere one, 4/3 pi r cubed.
You could have put it on there.
I would give it to you if I didn't. I would tell you what the formula is if you came up and
This is
asked.
too hard to remember the formula. Look at how hard it
That's not too hard math.
is. I gotta remember all this.
Danny, your brain is way more than sufficient to memorize these few little formulas. Your brain sneers at these little formulas. All right? What else?
Cube.
Pythagorean theorem. A cube? You want to know the volume of a cube?
It's pretty easy, actually.
All right. Rectangular? Nah, I wouldn't give you rectangular solid. But Pythagorean theorem, obviously, you should know.
Could you do a Pythagorean